Good morning, this is Hallicrafters Rehabs, and we're continuing on. We're going to put in this BFO switch on and off and this noise limiter switch, and let me get these cleaned up and prepped, and then we will move on with that, installing that. Okay, I've cleaned up these switches, and the nuts actually go on the face, so they stay loose until the chassis goes back into the case. And so we'll just do a quick test here. Nothing for continuity here. And this is the BFO switch. These wires were in such good shape, I kept them. Okay. All right. Let's make the connection. Boom. There we are. There's the. All right. Working fine. And I need to trim this. This is the noise limiter. Switch. Okay, on, off, on, off, okay. Then the volume control I cleaned up and put in, and it's got a two-conductor, these are two-conductor shielded cables that I had, which are a lot easier to work with. And so we're going to just check the check the resistance here. So that's 0.496, so 5 meg. This volume control is a 5 meg. Okay, and of course there should be nothing between this and ground. Oh yeah. That's actually, that would be 5 meg from that position, and this would be the variable, and there's 0.5 meg. Okay, so all of this is in. Next is the BFO, the on-off switch, and the phones. So we'll be back. So I've assembled everything. Here's a useless tiny chief. This 470 mica was leaky, so I had to replace that with a new one, and then there's this 270 was okay, so we'll put that back in. Here's a 0.01, and I've cleaned this up a little bit. Let's see how it tests out before I put it back together, and we'll record the numbers. So the full, let's put it on Henry's. Alright, so the full span of the coil from top to bottom is 145 microhenries. Writing that down. And losing a pin. Things roll down there constantly. Need to move the trash can. So from on one side it's 45.6, and on the other side you just do this 116. And the 116 side is what goes to the grid. I'll put a little green dot on it. So let me reassemble. Okay, while you're listening to the ultrasonic cleaner going with screws, I've put all the front controls in, and this back speaker terminal in the back. Added this, which will be needed for to service the output tube. Installed the phono jack, and this resistor was out, so I replaced it. And this resistor was in good shape, so I left that in for the. This is actually a tone control. It's just switchable. First, there's essentially no a straight path for the sound to get out, and then there is a resistance path to a small capacitor for medium. The straight path has no attenuation of highs, then there's a medium, and then there's a low. And then it's the on-off switch. And here's the on-off, which will be wired in later. So, I'm thinking I'm going to go ahead and put in the transformer, and then we're going to start working on the inside. So that's where I'm at now. Good morning. It's now 2 days later after my time with my father, and I just wanted to offer a couple thoughts here. For restorers, when you're restoring a radio, why do you see what you see? And it was explained to me one time, a triangle like this: quality, cost, and speed. Choose any two. So if you're going to be fast and you do it low cost, then you're going to have low quality. If you spend a lot of money and you put a lot of you do real low, you spend less money, but you have high quality, then you're not going to do it fast. If you want speed and quality, then your cost goes up. And every manufacturer is faced with this, basically. And they're really trying to do a balance rather than to choose any two. If you're the CEO, you want quality. And oh, by the way, you want a lot of sales like that. So that means cost is important. And then your marketing department is worried because Hammerland has a new model out there, and so does National, and they're getting market share. And so we need to get this SX-99 off the prototype bench and into production. And why is it taking you so long? So speed is important, but the cost people are saying, well, you're wasting, at least 10 feet of wire on every unit. So we need to pull those wires as tight as they possibly can and wrap them around the loops as tight as we can before we solder, and only solder one time. And then, but the quality control people are saying, you're sending me mud, this radio doesn't work. And then that's the kind of interaction that's always going on in manufacturing things. But in general, these things drive what you see as much as anything else, rather than the engineer that says, okay, I don't want to add inductance or capacitance or things like that in my design. So in the RF section, yeah, length of wire is important and things like that. But over here, it's how fast can I get it soldered and reliably and with adequate quality where I don't have to rework anything. So, I misspoke earlier when I was, I think this was the values, it doesn't really matter. I was looking at the BFO and and measuring the coil. And basically, it led me to, well, think about this a little bit further. This is the same kind of coil that's in the oscillator. It is an oscillator coil. And an oscillator coil makes a BFO stable. Now, I was looking at Jim Lindeos, and he's working with an S38D, and of course it did not have an oscillator, so it's just using a induced feedback with gimmick capacitors, which is kind of a really weak BFO in the S38s. When you put an oscillator in with a triode, this is the first half of a dual triode, the 6AC7, then you have a more stable BFO. So how does this work? How do oscillators work? Well, basically you have a coil with a total inductance of a coil, and you put a center tap. And what does the center tap to ground do? It makes the inductance in opposition to each other, because now the reference is ground in the middle of the coil. So this, when on this side towards the plate, the AC signal is going this way, is going to a peak. On this side, it's going to a negative. And then when this is going to a peak, that's going to a negative. And that is the oscillation that occurs in here, because the two are working against each other. And at what frequency is this? All right, this is a 470 picofarad mica capacitor, which happened to leak. I wonder if it was really mica. I guess it was. So, what's the frequency? Well, that's rather easy to figure out. What are we doing in a BFO? I think I've explained this in an earlier video somewhere. So, if you put this on a spectrum analyzer and say this is your reference signal, well, this is coming from the IF to the detector where it's injected. It's 455 kilohertz. You flip the switch here, and that goes to B plus. All right, that gives power to the plate, and now there's another signal. Ideally, the BFO is exactly like the 455, so you're working the design of these capacitors, and actually where you do this tap determines the voltage here, which determines exactly the amount of amplification that goes through this triode, so that you'll have the peaks relatively the same. So your pitch control is just a slug in here, which is attached to the knob. And so as you change the pitch control, you're changing the inductance. You're either increasing or decreasing the inductance. If you increase the inductance, what happens? The frequency goes down. I'll make this in blue. Like that. And if you go in the other direction, you're decreasing inductance when you remember it's 1 over the square root of inductance, I forgot the symbol, times capacitance. Henry's times, whatever, farads if you want to. So, so when you're in decreasing inductance, then this little peak goes this way. And the beat frequency is really the where these two coincide. So this is an audible frequency that you can see between the reference and here. Maybe that's 1,000 hertz or 1 kilohertz. Then you move it this way and it gets lower until the two coincide. And that's where you adjust the knob to 0 between plus and minus on the BFO. So that's, I hope that was not too, I always do chicken scratching by the time I finish with my Karl Rove whiteboard. Enough talk. So I did a little bit of work yesterday. I put on my high-powered reading classes. And this is not screwed in yet. Here's the transformer. The power output transformer is here, already installed here and wired up. It's not soldered. We're sort of working out where things are right now, so I'm not soldering anything until I'm really happy with where things are. Don't need an extraneous nut here. And I'm way off the screen. Let's bring this over here. Oh, we can't do that. We'll do that. We'll move the camera just a little bit. Oh, that's because I had it. There we go. Now we're back to normal. Okay, so the output transformer is right here. It doesn't connect directly to the output tube. There's a 10,000 ohm resistor right there. Just sort of working out where things are kind of going without really soldering over here and that kind of thing. I have not done, the first thing I will do is put in the heater circuit, because that goes closest to the chassis to prevent induced hum through this low-powered but high voltage, high amperage heater circuit, which carries about 40% of the current that the radio draws. Did a little bit of getting these in control, soldered in here. That's the noise limiter switch. Can't do anything with this until we have more terminal strips installed. And but just in my mind, working through where things are going to go and how they're going to go in the best possible configuration. So the first thing, and the other thing is that these tubes, here's an example. Every tube that's a metal tube has pin 1 grounded. You want to ground thoroughly the tube. Pin 2 is generally, and I think it is in all the cases, the ground for the heater circuit. And then in this case for the 6H6, the pin 8 is also grounded. So I'm using just, because it's pretty and it looks good, I'm using solder wick as my grounding wiring here is nice and flexible, and then when I get it the way I want to, I solder it down. So we have to go through and put that in before we even do any other wiring. The other thing is I just sort of randomly put these tube sockets in, and some of them are oriented 180 degrees wrong, so I have to fix that too. So that's where I'm at, and then we'll come back after we've got this in and we've got the heater circuit in. Okay, so right now I have got I haven't soldered this yet, but I have the filament lines put in and have finished doing the things like grounding pins 1 and 2 and that sort of thing, and these tube sockets. So the next thing will be to put in the B+. Good morning, it's another spring morning, and now I'm going to put in the B+, beginning with the capacitors and resistors. This is a total of 1500. What I'm doing here, and I lost what I was going to show you, so I'll come back. So this was what was there before, and I have a pretty good dislike for this kind of configuration. What you didn't see is the resistors around this that were cooked by a high temperature wire wound resistor. High temperature, I mean, there's nothing wrong with these. Omite makes real good ones. This one is supposed to be 1500 and is still, after all these years, 1484. It's a good one. I'll probably put it back in my stash, but I don't want to use that. Instead of a, I don't know, I believe it's 10 watts, I've got two 10 watt 750s in series. And my point behind that is simply, if we can fit it in here, and I'm not sure, 1498 is the total resistance, is to lower the temperature in the chassis and to preserve the components around it without having such high temperatures next to it. That's why I'm happy to put in a, now this looks like it's, oh, it's overloaded. Yeah. 1200. Right. So I'm dissipating the same wattage over a much larger surface area, and so the overall temperature, even though it's the same wattage, will be lower in the chassis. Now, it's a matter of fitting all the little chiclets in the space there and see if it'll work. So that's what I'm going to do next and see what comes out. Just one more thing. Basically, the B+ starts with the half moon. If you look at the old electrolytic can, it'll have a half moon, a square, and a triangle. Well, the half moon has this 33 microfarad capacitor, and then you have a voltage division between 1500, 1000, and 12,000 to provide the, and each one, after each voltage division, you have a filter 10 microfarad, and that's where you set up the plate and screen voltages of each tube. Okay, so this arrangement works. These will have to be bent up a little bit. They'll be up close to the bottom of the chassis, but they'll be run a lot cooler than this other resistor here, and they won't cook anything. And I had to get this, just lay this in here to make sure that there would be enough clearance for everything. So This will be the half circle. This one will be the box. And that will be the triangle. And that's how I'm going to wire the B plus from here on. And this is the 1,000 ohms to wherever it goes. Okay, so I've got the pretty much most of the B plus wired in here. First thing I did is I had to orient it this way because of the way those resistors fit. And so we've got everything run. These will be terminated on some one on an IF transformer and another on a terminal strip and so forth. So we're getting there. Now we're going to start working on signal, and to do that we'll have to install the this terminal strip in its place right here and recondition all that, and then this terminal strip goes in here and it gets all reconditioned. So plenty to do. That's enough for this video, and this is Hallicrafters Rehabs, having a great time. Be safe, and thanks for watching.